Hello class and welcome to part 4, and in this part 4 we're going to talk about evaporation. So what is evaporation? If you hang your wet clothes outside during sunny days, your wet clothes will become dry and you will see small pools of water form on the road during the period of rain, soon disappear when the sun comes out. If you mop the floor at home, you will notice that the wet surface of the floor turns dry after a while. In all of these cases, the water has changed into vapor or gas without boiling, and this is what we call evaporation. So, evaporation is basically the process where the substance turns from liquid to gas without reaching its boiling point. Both boiling and evaporation involve a change in state from liquid to gas. However, both processes have several differences. So, boiling occurs at the boiling point, and this is a fixed temperature. For water, water will always boil at 100 degrees Celsius. Evaporation, on the other hand, occurs at any temperature below the boiling point. Boiling is a quick process, whereas evaporation takes a longer time. It's a slow process. Boiling takes throughout the whole liquid. So all of the liquid is undergoing boiling. Whereas for evaporation, it only happens at the surface of the liquid. For boiling, there are bubbles formed during the process, and for evaporation, there are little to no bubbles at all. For boiling, the temperature remains constant as the liquid changes into a gas. For evaporation, the temperature can change during the process. For boiling, the heat is usually supplied by a heater. For evaporation, the heat is supplied from the surrounding. So, a formal definition of evaporation is the process when a substance changes from liquid to gas without reaching the boiling point. How does evaporation happen? So, let's talk about that. I have a video here from InPath Videos, and let's quickly watch this video. And this video shows you what exactly happens during evaporation. So, this is a glass of water. Let's zoom in and look at the particles. So during this process, each of the particles in this glass of water have their own energy. Some are faster, some are slower than others. Some are more energetic, while others are less energetic. And these particles gain heat energy from the sun. So you can see here the particles at the surface can easily escape the substance in this case. So if the particles at the surface have enough energy, they can break apart from the rest of the liquid and then go up into the air. Something like that. So the particles in the liquid have different energies. Some move faster and some are slower. So some have more energy, some have less energy. Some of the faster moving particles have enough energy to escape from the attraction of their neighbors. And when they have enough energy, they leave the surface of the liquid and then they become a gas. So this is basically what evaporation is. The more energetic particles have enough energy to escape from the liquid and then they become gas. So evaporation only happens in the surface because the faster moving particles at the surface, they are the ones that have the highest chance of escaping the liquid than the particles deeper in the liquid. So the particles deeper in the liquid, they may have a lot of energy, but it's very hard for them to go up to the top of the liquid to escape. So it is the particles at the surface, at the top surface first, that will have the first chance to escape. So this is why evaporation happens at the surface of the liquid and not throughout the liquid. One effect of evaporation is that when evaporation happens, it can cool down objects. Why does stepping on a wet floor with just your bare foot makes your foot feel cold? Why is it on a dry sunny day when you come out of a swimming pool into the open air you would feel colder? And why does it feel cold when there is a wind blowing? And this is basically because the water on your body is evaporating. So evaporation makes things colder or cooler. To answer that, you need to understand that for evaporation to happen, it requires energy so that the liquid will evaporate, or in other words, will become gas or vapor. In the cases above, in the cases explained in these three sentences here, the water on our body takes the energy it needs from our body to evaporate. And then what happens is that our body loses energy to the water on our skin. Hence, that is why we feel cooler or we feel colder. So, evaporation takes energy, or in this case specifically heat energy, from somewhere else. Hence, this object, this somewhere else, loses energy and its temperature decreases. So, let me elaborate that a bit more using the examples that we explained here. So, let's say this is your hand, and your hand is wet with water, and that's the water there. And of course, if you are wet, if your body is covered in water, you will feel cold. Why is that? That's because of evaporation. So you have to understand what's happening here. For the water to evaporate, it needs to get its heat energy from somewhere. Where does it get its heat energy? It gets its heat energy from your body. So the heat energy from your body goes into the water, and then the water gains more energy, it gains more heat energy, and then the water can evaporate. The reason why you feel cold is because the heat energy from your body is being taken by the water in this case. And because your body has less heat energy now, that's why the temperature of your body decreases. You feel colder. Okay, so evaporation takes heat energy from your body, and that's why evaporation makes you feel cold. So here are four examples of the uses of evaporation in everyday life. Number one, cologne or perfume are made from volatile liquids that have a low boiling point. Hence, they would easily evaporate away and become gas, and then you can smell the cologne or perfume. Wet clothes or puddles can be dried up in open air, and this is thanks to evaporation. Number three, if someone has a high fever, we usually put wet towel or we use water so that as the water evaporates, heat is being removed from the patient's body. In this way, we can keep the temperature of the patient down and the patient wouldn't be in discomfort. Example 4 here. Together with the process of condensation, evaporation is applied in the cooling process of refrigerators and air conditioners. So to summarize, what do you need to know for evaporation? Make sure you know the difference between boiling and evaporation. So this table here will be important for you. Make sure you know how to define evaporation, and evaporation can be defined as it is the process when a substance changes from a liquid to a gas without reaching the boiling point. That's the definition. Make sure you are able to explain in terms of the particles how does evaporation happen. So you will need to explain that the particles in the liquid have different energies. Some of the faster moving particles have enough energy to escape from the attraction of their neighbors and therefore leave the surface of the liquid and become a gas. So this is basically how evaporation happens. Make sure you understand how evaporation can cause cooling. That's basically because evaporation takes energy from the object loses energy, therefore its temperature decreases. And then make sure you're able to state a couple of uses for evaporation. So evaporation is useful for cologne or perfume, useful when you are drying wet clothes, useful when someone has a high fever and you want to keep the temperature down, and also evaporation is useful in refrigerators and air conditioners. So in part 5, we're going to look at some of the things that can affect the rate of evaporation.